complete 8.1. Yeah. 8.2, our second question. Our another interesting topic, impact of organized data. 8.2. Yeah. So in this unit, I like to look at a new question. Yeah. Our problem number 5, element uniqueness problem. A simple problem, yeah, but we can learn something interesting. Yeah. First, the problem. Given an array. All right. Question. How to check if all the elements are distinct? Very simple, right? Yeah. So, and then there are many ways to do the checking. Yeah. But our goal, we want to find the best way, right? The best algorithm we can find. Yeah. Here. Yeah. All right. So let's look at the discussion of the solution. Yeah. Method 1. Yeah. Here we apply 2 methods and we can do comparison. So method 1, from our title of this module, the brute force method. Brute force method. Yeah. So I think you can guess the meaning, right? The brute force method. Yeah. Here I can describe this method a little bit. Yeah. So what is the brute force method? Yeah. Yeah. Later, yeah. First, let's apply the brute force method. Later, we can, summarize a little bit. Do nothing to organize data. Yeah. So given an array, we just do the processing directly. We do not do any data organization work before we do processing. Yeah. We just do, comparison directly on the given data. So that's the method 1. All right. That means in the data organization part, there is no cost. We do nothing, so there is no cost. Yeah. It looks like some saving here, right? Yeah, because no cost, Good saving. Yeah. Later you will see, the final result could be different. All right. Yeah. So when we do the work, yeah, here, that's the work. Yeah. So here, I draw a diagram, show you a special case for the given array. Yeah. All right. Here, these numbers we can treat as the position numbers. Okay, position numbers for the array elements. Yeah. All right. And how do we compare elements to see if there is any duplicate element in the array? Any element that equals one of the other elements in the array, then our function returns true or false. Okay, element uniqueness problem, when our elements have that uniqueness property, return true. Okay, otherwise, if there is at least one duplicate element, return false. Our checking function returns false value. Okay, yeah, that's simple. All right. When we do comparisons, yes, straightforward comparison, brute force method, straightforward comparisons. The first time we want to check if the element in this 0 position, 0 index, the first position, if this element is duplicated somewhere else by comparisons. Okay, so to check that, we need at the most n-1 comparisons, right? No. we need at the most n-1 comparisons. Yeah. Because if we are lucky, we do not need that many comparisons. Yeah. Okay. All right. After checking the first element, then we may need to check the second element with the remaining elements, right? The following elements. Yeah. The second one, we need to do comparisons with the following elements up to n-2 comparisons and so on. Okay, yeah, until we do the last comparison. Last comparison compare the last two elements, so just the one comparison. Okay, yeah, so that's all the possible comparisons you need to consider in order to determine if the given array has that uniqueness property. Okay, yeah. All right, yes. Now we can do some analysis of efficiency. Yeah. The best case efficiency, yeah. What is the minimum number of comparisons you need to do? The best case, yeah. Very easy, just the one comparison. Yeah, think about in this special example, yeah, the first two elements happen to be the same. Okay, yeah, here I understand those numbers as values. Yeah, so that's okay, right? Just one special example. 0 equals 0, the first two elements happen to be the same. So after your first comparison, you can return true or false. False, right? Yeah, uniqueness. Yeah, because if all the elements are unique, then your checking function returns true. Otherwise, false. Here, not unique, right? The first element is not unique. So your checking function returns false. Yeah. So the best case, one comparison. Okay, all right. Similarly, the worst case efficiency, yeah, the worst case efficiency, yeah. Here, I give you a special example. The last two elements happen to be the same, okay? Yeah. But in order to find that pair of elements, you need to do all the possible comparisons, right? Yeah. So in that case, you need to do this many, adding up all these numbers of comparisons. So our worst case is this expression, 1/2 times n-1. Okay, yeah, the worst case. Yeah, so you can see so different. Yeah, best case, worst case. Yeah. Another question: how about the average case efficiency? Average case. So you need to consider all the possible cases, and you need to find a way to get a fair average. Okay, the right way to find the average case efficiency. Okay, yeah. So recall we did it in that search problem, linear search. Yeah. In our linear search problem, we find the average case efficiency using the weighted average. Okay, yeah. So here we recall the linear search problem. All right, yeah. And there we use the weighted average. Way, okay, to calculate the average case efficiency. Yeah. Here we have the similar situation. Okay, here we have the similar situation. Yeah. And in that problem, so there is a, we need to use some probability, P, some probability. Okay, yeah. And here we have the similar situation. We also need some P for certain probability. Okay, yeah, yeah. The probability for the elements of the array to be unique, that probability, okay? That information not given, right? Yeah, yeah. So the probability P, the probability for the elements in the given array could be unique. That number should come from experiments, right? Statistics of the, history data. From this probability comes from statistics on the history data. Okay, yeah. So we don't know that number. Here, in the general situation, we don't know that probability P, but in the real world application, you have a lot of history information, so you should have that history data. So you can do statistics, so you can, get some approximate probability number, so you can use in order to calculate this average case efficiency. All right, yeah, here, I just do some review. Yeah, all right. Then, this is the first method, first solution, now, using the brute force method. Okay, yeah. Here you can see when we apply this brute force method, we do not use any special technique, right? We just do straightforward comparisons. We do not do any relatively more advanced techniques. We didn't apply any special techniques, just straightforward, based on our intuition, we do straightforward solution, brute force method, okay?